Now, this is a very tricky question. And the reason I say that is because if you just look here at essentially the y coordinates, they're calling it c, and then instead of w, we usually use x, but it looks like it's just doubling every time, right? And that would be an exponential kind of relationship. However, the only way you can just look at the y coordinates is if the x coordinates are increasing by the same amount every time, like usually 1. But notice they're not. So instead, we have to look at these as essentially ordered pairs. And so notice one way you could do this is you could go to stat, edit, which means enter. If you have anything in your lists, you could go to the actual L1, let's say, press clear and down. Let's go over to L2 and do the same thing, clear and down. And then let's input in our L1 all the W coordinates, as they're calling it. Oops, I want to be careful there. And then same thing, let's do that for L2. Looks like my 0 is struggling a little here. And then what we want to do is we want to go to stat plot, so that's second y equals. We're going to turn the plot on. So to do that, we'll press enter. We'll press enter again on. And if I just graph, you're really not going to see much. Oh, you got to make sure any lines are gone. But the idea is, in this case, because of my window, I'm not getting a good view. So I could go to window and I could say, well, I want to make sure I cover all the way to 32. So maybe I'll go from 0 to 32 and count by something like, I don't know, 4. So that I can cover all those without having too many tick marks. For the y-axis, I could start at 0. I just need to make sure I get all the way to 960. So to about 1,000, we could say. In that case, I would count by 100. So there's only 10 tick marks. And then let me go ahead and press graph. Oh, and we can see it. Now, does that look exponential or linear to you? It looks very linear. So that's one way we could have done it. What we could have also done is notice that this is increasing by 1, then by 2, then by 4, then by 8, then by 16. And if we do the same thing down on the y's, it's increasing by 30, then 60, then 120, 240, 480. And notice if you do division, essentially change in y over change in x, you consistently get 30. So that means it's linear. More specifically, the slope is 30 in this case. So that means it's linear. We could eliminate exponential, and it was increasing by about 30 each time. We just discovered that. And so that means the correct answer is A. Another thing is, if you recognize that it is linear, but you're unclear on the slope, you could go to our program slopeint, which is program number 3. Type in any sets of these ordered pairs. Let's say I use 260 and 240. You'll see that the slope is 30. And then an important thing is, you want to make sure once you're done with this, if you did use the stat plot, you can go back, turn it off, and then to get our window to no longer be kind of crazy like this, you just press zoom 6, which is the standard window, and it goes to -10 to 10, -10 to 10.